Today we're going to talk about some of the different ways we can manipulate our trig graphs. The first way we're going to talk about is taking our graph and stretching it vertically. If you look at my picture here, the blue curve is the regular sine curve. If I want to stretch it and make it longer, instead of going from 1 to -1, I could stretch it like the green curve from 2 to -2, or stretch it even more like the red curve from 3 to -3. You can stretch it any amount you want. The way this works in an equation is if you have some number k in front of that sign, the number out front is the amount you're going to stretch it by. So if you look at that green curve, you'll notice that it says it's 2 sine x. So instead of going from 1 to -1, we multiply all of our values by 2, thus stretching it by a factor of 2. And now it goes between 2 and -2. To get it to go between 3 and -3, you'd put a 3 out front in front of the sign. So let's practice this skill a little bit. In our first equation, f of x equals 3 sine t, we're taking the normal sine curve and we're stretching it by a factor of 3. So you draw your sine curve the same way you normally do. Starts at 0, goes through pi, ends at 2 pi. Just notice this time we're going to change this 1 to a 3 because it's going to stretch up to 3 and it's going to stretch down to -3. All I care about with these graphs is that you have the right shape. Obviously it's a sine curve. I want you to label how high it goes and how low, with the 3 and the -3. Also put a few marks on that x-axis to give me a rough idea that you know where points go. At least the pi and the 2 pi. You can throw in the pi over 2 and 3 pi over 2 if you want also. You can continue the curve on the other side or keep going on the right side as well. All I really care about is that you have one curve in there, and that's it. Trying 1/2 cosine t down here, same idea. Now we have a cosine graph multiplied by a factor of 1/2. So instead of going all the way up to 1, my cosine only goes up to 1/2 and down to -1/2. So in this case, you're actually kind of shrinking it. Sorry, that's not a good curve there. Instead of stretching it. I'm going to fix that graph a little bit for you. The next transformation we're going to talk about is called the reflection. Right now we're going to reflect over the x-axis. So as you can see, this blue curve is the original sine curve. And when I flipped it over the x-axis, I get the red sine curve. A reflection in an equation is noted by the negative sign in front of the sign. So where the blue curve is sine of t, the red curve would be negative sine of t. That negative sign takes all the positive values and flips them, makes them negative. All the negative values and makes them positive. So it should make sense that it would flip the entire graph. So let's practice a little bit. The first one is negative cosine t. Now, if it's helpful to you, you can start by drawing the regular cosine of t. And then go through and change it by flipping it over the x-axis. You don't have to draw the original, but as these get a little bit harder, that might help. So you can do that if you want. Just make sure you label for me which one is your final answer on a test or a quiz so that I know. Now the next one is a little bit of a combination. It's -2 sine of t. So we're going to do two things here. The 2 is going to stretch it, and the negative is going to flip it. Now, the better you get at these, the more steps you'll be able to do at once. You can do as many steps as at once, or as few steps as you want to. Okay? Don't feel like you have to do it in all one step if you can't. What I'm going to do is I'm going to start by drawing my sine of t stretched by a unit of 2. So I'm going to make it go up to 2, down to -2. So let's stretch up here. And now I also need to flip it. So I'm going to take everything I just drew and I'm going to flip it upside down. And that is my final answer. If you could do that in one step, that's fine. If you can't, that's fine too. So we've already covered a vertical stretch where we take the whole graph and we stretch it up and down at the same time. Now we're going to talk about a vertical shift. A vertical shift is when you take the entire graph and move it just up a certain number of units or down a certain number of units. In this picture here, the blue curve is my original sine curve. And then I took that curve and I moved it up a certain number of units and it became the red curve. Formula-wise, the way you shift a curve up or down is by adding something to the end of the equation. So sine of t plus 2 would move the entire graph up 2 units, or down if it was negative. So to practice here, we have cosine of t plus 1. Our original cosine curve looks something like that. Now we need to take the whole thing and move it up 1 unit. So now instead of topping out at 1, you top out at 2. But instead of going to -1, you actually end at 0. I sometimes like to draw little points just to kind of help me out a little bit. So there you have cosine of t plus 1. Next one, 2 sine t minus 2. Now, notice we have a couple different things going on here. We have a stretch of 2. And we have a shift of -2. First thing I want to warn you about is making your graph big enough. The graph that I pasted on the slide here is not big enough. There's only a 1 and a -1. Notice you're going to stretch your graph from 2 to -2, and then you're going to move it down 2, which is actually going to make it go all the way down to -4. So just be careful when you're making these because it's easy to kind of just draw a graph like I did here and not have enough room. You want to make sure that you create a graph that has enough space for you to get the whole thing in. So we're going to change our scale there so that we have enough room. And if you're not being careful thinking ahead of time, just leave yourself some extra space so you can always go up or down if you need to. So let's get started. I'm going to start by making a graph with just a stretch. So 2 sine of t would start at 0. It would go all the way up to 2, back down to 0, down to -2, up to 0. So that takes care of my stretch. I also need to shift it down 2 units. So I'm going to put in some points here. So instead of starting at 0, I'm going to start at -2. Instead of peaking out at 2, I'm going to peak out at 0. Instead of being at 0 again, I'm down at -2. instead of bottoming out at -2, I'm bottoming out at -4. And then we're back at -2 again. Sometimes I think this is helpful. You don't have to do that, but it kind of, before you draw the whole curve out, make sure you have it right. So here's our graph with a stretch of 2 and a shift of -2. So that covers all of our transformations that we're going to talk about right now. The next thing I want to talk about, just really quickly as a side note, is what an even and an odd function is. Even and odd functions are terms that we use to describe types of graphs. An even function is a function that is symmetric with respect to the y-axis. So basically that means any negative x has the same value as its positive x. So if we look and we choose some random x here and some random x, the negative of that x is going to have the same value. So if I picked this x here, this x there, they have the same value. Every positive and its associated negative value has the same value. Notation here is basically what I just said. The function at -x is equal to the function at positive x. This is what we call an even function. It's nice because it means I don't have to worry about the negative so much because I know it has the same value as the positive. So if I can figure out the positive, I can also figure out the negative. This picture here is the cosine function. Cosine is an even function. Whatever x value you choose, it has the same y as the negative x does. An odd function is a little bit more complicated. An odd function is symmetric with respect to the origin. Basically, that means if I take an x value, its corresponding negative x value has the negative version of the same value. So if the x I chose was, the y was 0.7, the negative x would be -0.7. So here's your notation here. F of -x, so the function at -x, is equal to the negative of the function at positive x. Notice sine of t is the graph here. It's odd. So whenever you have whatever value positive x has, the negative x has that negative value. Tangent is also odd. We draw a tangent really quick here. Same thing happens. They have the same value. One's negative, one's positive. We're going to talk more about even and odd functions and how they can be used later on, but here we're just introducing them a little bit.